This is the 5th lab for this course. We're going to be working with a pressure process here on our process trainer. So in this vessel over here, we're going to be controlling pressure in this closed vessel right here. The way that it's set up is we have instrument air running through this line right here. It goes through this regulator. So coming in at about 60 psi, regulated down to 5 psi. If I turn this gauge back on here. Yeah, about 5 psi. And then it comes out of this line right here and flows up and into the top of our vessel right here. So that's supplying the pressure, the air pressure for our vessel here. We're sensing the air pressure off this line right down here. It comes down to this differential pressure transmitter that we're using to measure the pressure. And the transmitter is wired in. You can see this wiring goes down over and it connects to these top 3 terminals here. So positive, negative of the transmitter and the shield running back up top here. Then connects up over to our delta V control system. So it's brought out on these wires here and then connects over to card 1. And if we look up here, card 1 is an analog input card into the delta V control system. On card 2, we have a device. You can see card 2 flowing out, and then it's wired up to right here, which if we go on to the end of our bench here, you can see these 3 wires right here. They flow down on this line right here, this wiring, up to our control valve right here. It's connected to our control valve. So our control valve is venting to atmosphere. It is controlling the pressure in this vessel. It's controlling a back pressure. So when the valve opens, it relieves pressure and the pressure drops in the vessel. So that's what we're using to control. Now, if we have a look over here, that same process is set up right here on our delta V control system. On the HMI, you can see the air flows into the vessel, pressure measured right here, and the line going out here to our valve allows the air to vent. So there's a controller here that's inside the delta V control system that is calculating a signal that goes out and over to our valve here. We've got this characterizer set up too. I've got a button, so if I want to enable a characterizer, I can do that. If I click enable, you can see then it gives me the option to disable it. And this here changes. The signal is now coming from the characterizer over to the valve. If I disable it, this just indicates that the signal is now coming from the output right from the controller. So what we want to do here is we want to have a look and figure out if this process is linear or not. If it's non-linear, then we'll have to maybe do some stuff here to make it easier to control. So our first step to figure out if it's linear is to do like an input-output graph. We input a signal to the process and then watch what the process variable does. Would be like our output signal. So if we have a look here, I can change the controller output right here. I'm in manual mode right now, and we can watch what our process variable does. You'll also see it happen here on the trend as well. So we're at 0.1 psi right now, and if I step this to 5%, we don't get much change. We're still at 0.1. We'll go to 10. Still not too much. We'll go to 15. And keep in mind what we're doing right now is as the signal increases, the valve closes. It's fail open. So as we get to 100%, the valve will be fully closed. When it's fully closed, we should see our pressure build in the vessel here because we're not venting very much pressure. So we're at 15, 20. It's starting to rise a little bit, 0.2, 25, 30, 35, starting to rise more, hit 40. We should start to see it change more and more here. 45, 50. So it's a fairly fast acting process. So I'm not waiting too long between steps. But what you can see here is from steady state to steady state, our steady state gain value is increasing. when we increase the input to the process, the output, the PV, is really starting to change. Especially when we get to 60 and 65 here, we've had some pretty big jumps, right? So this confirms that our process is nonlinear. Yep, we're getting some pretty big jumps here. And looks like now it's starting to taper off again, so the gain isn't quite as high at the high end. So the gain was fairly high right in this area right here. So we've confirmed that it's nonlinear. And what I want to show you now is I've plotted all of our values here. I've already done this. I stepped it from 0 to 100%, and our process variable, the pressure increased as we went here, you can see. So what I then did next is I took this, it was our transmitter is set up for 0 to 5 psi, and actually at 100% it went a little bit above just because the valve was fully shut. But I took that, divided by 5 psi and multiplied by 100 to get a percent PV value for us. So we've got a percent PV value here. So we've got these two values. This is like our input to our process, this is like our output to our process. So the output would be on the y-axis here, and the input would be on the x-axis. And so you can see here, this is nonlinear. This is showing us that our process is nonlinear, and our gain being the highest, somewhere right around 70 or 65% right here, right? So what I want to do now is we're going to attempt to tune this process. We're going to try to tune it around 40% controller output, and then we're going to try to tune it around 70%, and just kind of see what happens here. I'm going to bring it back down to 40%. Wait for the pressure to stabilize here. It doesn't take very long. And we're going to switch this. We're going to set our, just to kind of speed things up, I've already tuned this, but we've got this controller. It's set up for gain scheduling here. So this will come into play maybe a little bit later here in the lab. But the first thing that we want to do is we want to set our gain value, and I know the gain value that will work for this, so I'm going to enter it right now rather than us playing around. A gain value of 2 and a really high reset, which is already inputted there, and our rate value of 0. So we're set up in proportional only. We can do the Ziegler-Nichols closed loop tune now. So now what I'm going to do, 40% gain value of 2, I'm going to go and step this up to 0.8 psi. And wait to see, oh, we got to put it into auto first. Let's put it into auto. Step this to 0.8 and see if we get some oscillations. So it looks like our process is oscillating here. Are the oscillations getting smaller? Just want to make sure that they remain steady. We'll see here. I'd say we're pretty close to sustained oscillation there. So now what I'm going to do is I'm going to go and enter in, I'm going to apply the Ziegler-Nichols closed loop tune calculations and enter them into the controller. I'm not going to give those to you because that's something that you're going to have to do for this lab. But I'm going to go and enter them and we're going to see what happens. Before that, we should probably discuss, we used a gain value of 2 here, proportional gain of 2. And it looks like our period of oscillation is right around peak to peak here. I would say we're pretty close to one full division here, which is 4 seconds. So we'll use 4 seconds as our period of oscillation. All right, so I've entered in our tuning parameters here for a Ziegler-Nichols closed loop for proportional plus integral controller. And I'm gonna go ahead and step this back down to 0.4. So you should see it come down. It should do something like quarter amplitude decay. Looks pretty close. We'll step it back up to 0.8. See how it does. Looks something like it kind of oscillates and then stabilizes again. So it looks kind of like quarter amplitude decay, I would say. But now we said our gain value was quite high when our valve was open around like 60, 65, 70%. So let's try to control up in that zone. We'll move this up to we'll go up just by small amounts here. We'll go up to 1.5. So yeah, it's definitely oscillating more here. And let's step this again. We'll go to 2. Oops, not 20. We want to go to 2. So it doesn't look very stable now because you can see it's in sustained oscillation here. Let's go to 2.5. Definitely in sustained oscillation. So this isn't very good control, you can see. We don't want to be constantly oscillating like this. So what we need to do here is try to make this better. So we're going to tune it at around 65-70% now. So we've got our tuning values for that 40% range in our controller output. Now we're going to do it for a controller output right around this range here where we have this sustained oscillation. All right, so I've set our controller output to 70%. We're in manual mode here. And if we go over here, I've got the gain now, proportional gain set to 1 and a really high reset. So we're in proportional only mode with a gain value of 1, and we're gonna do the Ziegler-Nichols closed loop tune here again. And so what we're gonna do is put this into auto, and we're gonna let's step it to, we'll step it down this time actually. We'll go down to 2.5%, or sorry, 2.5 PSI per set point. I'll just watch it for a little bit and see if the oscillations are sustained. And it looks like they're pretty close, yep. I'd say they're not really growing or diminishing yet. So, and it looks like our period of oscillation here again is about that 4 seconds. So it's about the same period of oscillation, but our proportional gain here is only a value of 1. So I'm going to apply those calculations and I'm going to input them in and see how this controls with the new tuning parameters. All right, so I've inputted the new tuning parameters here, and if we step this up to 3, oops, not 30, just 3. Here we should see, hopefully, it shouldn't be in sustained oscillation there. Something looks kind of like quarter amplitude decay, which you can see we have a little bit of an oscillation here, and then it looks like it's going to stabilize right at 3. So there, our tuning is a lot better. But now, it would probably be, it's going to be a little bit sluggish now when we go down to that point. We'll take it down to 2. See that quarter amplitude decay a little more now. And 1. And now when we try to get down to that that point 1, we'll probably see it quite, or that point, we'll go around about 0.5 there. And that's when our controller output here is going to be getting down to close to the 40 range. And we're going to see it probably be quite a bit more sluggish here. So it's going to really take its time to get down. You can see it's really slow. So we've kind of got these two zones here where we need different tuning parameters, right, to fix the problem. So what we can do is we can use the gain scheduling parameters in our tuning here. So what I'm going to do, I'm going to go ahead and I'm going to set that up for you guys. All right, so we're going to set up our gain scheduler here. Right around here, we want to use those higher gain values here, tuning parameters, the higher tuning parameters here, because our gain's really low. The gain of our process is really low. But here we want to use the tuning values that have a lower gain right in this region. So it appears that about somewhere around 20%. So let's see, somewhere when our process variable is around 1, looks like a good starting point to switch over to the other tuning parameters. So we're going to be referencing the process variable. So when it's around 1, I would say, when our PV is around 20% here, looks like around 20, 22. So yeah, we use 1. And then looks like maybe we can taper off and use those higher gain values again once we get about to about 90%, which would be around 4.6 psi. So we'll use one point. We use 1 and yeah, 1 point. Sure, we'll use 1.1 and 4.6 for our values. So looking over here in our detail window for our controller, region 1 here is, I just have the I left the ultimate gain values here for Ziegler-Nichols in here, because you're going to calculate those other values, the tuning parameters for these regions. But region 1, we want it to start here. I need to change these. I want this to be at 1.1. It's referenced to the PV, and 4.6 psi. Right, and we'll give it a deadband of 0.2. So now we've set up our regions here. So when we go into region 2, that's when we're going to be using those other tuning parameters. And when we hit region 1 and region 3, we're going to be, you can put in different ones here, but I'm just going to use the ones we used down in the lower, when we were down around 40% controller output. So I'll enter those, and then we'll see how this tunes, or how this controls with the new tuning parameters set up with the gain schedule. All right, so I have those regions, I have the gain schedule all set up now. And let's do this. We'll go up by 0.5 increments here. So let's go to, we'll go up by 1 psi, so 1.5. Looks like it did pretty good there. It's already pretty much stabilized. A little bit of almost a quarter amplitude decay there, kind of. And we're at our we're right at our set point. Let's go to 2. And we're pretty much we're at our set point. Looks good. Let's give it a decent jump here. We'll go to 3. Yeah, so now we don't have that sustained oscillation. If we jump back down to 1, and let's go down to 0.5. So there you can see it's a lot more responsive. It brought it down to 0.5 a lot faster here when we came down to this region. So it's using the two different tuning parameters that we determined there. So it looks like it's working pretty good now. All right, so don't mind this here. I just was changing some stuff here. But the next thing that I wanted to show you is applying and setting up and using the signal characterizer now. So we have a characterizer here, block setup. If I enable this, it'll enable the characterizer. I've already configured it, but if I take you over here in Delta V, this is a Control Studio for our, actually I'll show you Delta V Explorer first. But we have this control module right here. This has our programming for the control loop that we're using in it. And so if we were to right click on that and open with Control Studio, then we would get this setup. It's all function block programming, you can see. And this is the templated block in Delta V. You kind of just copy paste. It's a template for gain scheduling. So we're using this, but we've added the signal characterizer block right here. So this is what I want to draw your attention to. If you click on that, it has an X curve and a Y curve. The X curve is our input to the signal characterizer, and the Y curve is the output. So if we were to, what I'll do actually, because I don't want to show you the values that we need to put in here. If I could drop in another one. Signal characterizer block right here. So if I select it and I double click the X curve here, so you can see on the X curve, we can input up to 21 points, or actually 20 points, including 0 here. So we can put all of our points in here, and these are all be like our percentages from our either our controller output or our process variable. And the X is the input and the Y is the output. And so you can see they're identical right now, but one would have to be changed. And so we would use that to set up our signal characterizer. So this is set up, and I can enable and disable it. And if I go back over here, that's where I would be. I wanted to show you where I'd be entering all those values that we got from our graph there, and I plotted in Excel. But I've entered them already, the correct ones in the correct XY array, or table basically. And if I click enable now, I want to show you what this does. So it's enabled. We're in manual mode right now, and let's put our controller output to 0. We'll start at 0. We'll go to 5%. %. And hopefully you can kind of see, it sure looks like, you can see our controller output. It looks like our process variable is almost following it now. Let's go to 15. So when we went from 10 to 15, it looks like our process changed by almost the same amount. So I hope you can kind of see what's happening here. If the controller output, if our controller output and our process variable is changing by the same amount, and also take a look at, right now I'm outputting 25% with the controller, but the characterizer is telling the valve to be 57% open right now. We go to 30. You can see it change here by about the same amount. Go to 40. I'm going to take some bigger steps here. And look at that, by the same amount. Go to 50. So hopefully what you're noticing here is using this characterizer, it made our process basically linear now. And the way that it did that is it's changing our controller output value here, right? So we're stepping it by a certain percentage, and it's sending a signal to the valve to move the valve by the right amount to make the process almost linear. So what this does now for us is we should basically be able to tune this process at any spot. So why don't we tune it right around 50%. Set this to 50%. And while that's changing, we'll go over here. Our gain value is at a value of 1 right now. Let's see what that does for us here. So 1, and yeah, okay, so let's see, we'll change this to auto. And let's step this up to 3. See if we can get it to oscillate here. And I didn't figure this out ahead of time, so yeah, it looks like we need to up our gain a bit. Let's try 2. Step it back down to 2.5. Looks like it tried to oscillate there, but not quite. Let's try 3. All right, so I calculated the tuning parameters with Ziegler-Nichols closed loop, and now I'm gonna bump this to 2.5. And it looks like I brought it to 2.5 actually relatively quickly. Let's make a decent jump. We'll go to 4. So there should be, with Ziegler-Nichols closed loop there, we should see some we should see like quarter amplitude decay kind of here happening. So it looks like it's right at 4 here. It looks like it's holding pretty good. Yeah, so it looks, let's go down to 3. It's coming right to 3, you can see right here. That's good. 2. Slight overshoots going back. Not bad. Let's go down to 1. And this here zone was where we started to get, see how it does. Well, it's starting to stabilize, it looks like here. We're right around 1, so this is where we kind of had, where it was quite sluggish before. But it does look like our controller output here is kind of oscillating. So we might have to lower our gain a little bit, but let's go back up to 2. So we don't want to see our valve moving around a whole lot, which it looks like it's doing pretty good there. And right here it looks to control really well. So just down around that 1 area down there is maybe where it could be. We could have it, we could maybe lower our controller gain, and that might help fix that a little bit. But for the most part, it looks like it's tuned up pretty good now. You can see right here and right here, they almost look identical, the responses, right? If we go to 4, just watch that controller output. We don't want our valve to wear out. We don't want it to be oscillating too much. Looks like it's not doing too bad. It's going to stabilize here pretty quick, I think. Yeah, looks pretty good. So you can see on all those bumps there. So that characterizer there linearized everything now. And so now we can, doesn't really matter where we tune this, the tuning parameters, we got a single set of tuning parameters that are going to work just about anywhere within the range of the process variable. So hopefully this video helped apply some real world examples of using of taking a nonlinear process and either linearizing with a characterizer or using the gain scheduler feature here in Delta V to use more than one set of tuning parameters for better control. So there'll be some questions to answer on this lab. Thanks for tuning in.